Hi guys, I've got some important news that a lot of you have been patiently waiting for over a year to hear me say, and I'm not going to delay you anymore. I'm going to just tell you straight away that we have fixed the data logger issues that we had with the trimagnetometer station, and you're looking at the data now that has been recorded onto the SD card. It's a simple fact now that we have got this sorted, that we can just now process the data, and I've just been playing about with today, because I only really cracked the back of this last night. I've been looking into Excel spreadsheets so we can have a look at the clear data. I'm going to show you that in a bit. I just wanted to tell you what the problem was. Now, most of you know about a year ago I set about the task of designing, building and logging the data of the headings of the magnetic north pole. We can do the south pole with this equipment. It's not a problem. Quick calibration, get some equipment down there. We've got people actually that have showed interest in having some of this equipment in New Zealand, so we'll be talking about that over the next coming weeks, months, and we'll try and get something sorted out where we can have this equipment now spread out at different parts. I mean, there's one going over to Virginia. If that man's still interested in setting it up over there, the idea is that we can spread the data collection points out now internationally, have that data then transmitted up to the internet. We'll have a program sort out the the information that we gather, and we'll be able to get a triangulation with some mathematics and of where the magnetic north poles are, instead of just a direct heading, which will be what I'll be putting up on the website over the next few weeks. Like I say, I'm just sorting out I want a nice looking graph. We've got 3 magnetometer readings, and there's going to be some random uncertainties. Let's have a look at the stuff. But before I do, there's so much really I wanted to just tell you about what I've been doing over the last year. I mean, I know a lot of people probably lost hope in me getting this finished. Getting the problem of the data logger sorted. It's taken 12 months. But the problem's been simply, I've had to teach myself electronics. Not only putting the equipment together, and this was a bespoke project. I mean, just to give you for example, we've got magnetometers that are transmitting data to a breakout board. The breakout board's transmitting that data then wirelessly to a receiving station, and the receiving station's recording it on the SD card, which we can whip out whenever we want, put another one in, and then process the data. So there's been a lot of learning curves for me. I'm not a programmer. I probably am a intermediate now programmer on this stuff. But one of the problems we had, and why it couldn't be fixed, is because it was 2 problems. One, it was a hardware problem with the SPI, and the other problem was with the program itself. But with the dedication and continuously, trying to resolve this problem, someone we was talking the other day, someone mentioned that the famous quote of Nikola Tesla, I've not failed, I just found 1,000 ways it didn't work. That was the exact case with this, only with me. The hours that I've sunk into this were physically and emotionally just draining the life out of me, to some points where I would clearly spend days from the morning just grabbing a quick bite of sandwich or something in the day till late on the evening, and absolutely getting nowhere, and it was just soul destroying. But we were there now. It's taken over a year, and we've got the equipment. We've not just got good equipment, it's bespoke equipment. No one will have this setup anywhere else, and it serves a specific purpose, and that is to track the heading of the magnetic north pole. Like I said, we can do the south pole as well. Now we've busted the problem on this, we can log other sensors. The sensors shouldn't be a problem just to add to this. So we're going to add barometric, we're going to also add temperature, and we're also going to put an FMG3 sensor, a meter, into the ground to protect it from interference. And we're going to measure with that the magnetosphere strength, which is currently depleting. So, you know, we have made a massive leap forward with the progress of over the last few days and weeks. I said I'd do this. I've done it. You know, we're now going to start looking at some data. Why did we set out to do this in the first place? Because it was my theory, and you know, I think it's a new study completely into the geomagnetic anomaly. That there is a two-stage process, and the first stage is that over the last 100 years, for instance, it has been migrating through the strong field lines, and hence it's been moving slowly, and that is up until in 2014, when something entirely different started to happen. As it was tracking over towards Siberia in a nice straight line or a vector, it suddenly deviated southeasterly, and when it started to do that, I believe it started to buff it into those weaker field lines. If you remember the experiment I'd done with the compass and the magnet, we've seen that when the compass needle went into the weak field lines, that was when it actually shifted. And I believe we could be very close to that point where we start to get an increase in speed. So, you know, the fact that we've managed to sort out all these problems and we can start logging the heading, we can watch it daily if we want, weekly, or, you know, as this machine will do, take over 8,000 readings a week. We can look at, you know, probably 10 or 15 times every minute. So, you know, we've got an accurate account as to what is going on. This information that we're gathering, you know, the data on the with the magnetometers, is not just going to show us the heading. It is also going to, as a secondary, you know, and not by default, should I say, it's also going to allow us to watch what happens when solar waves buff it off of the magnetosphere. We're going to see that on the readings, and we're going to see real time. So, you know, the data that we're going to be gathering from now on, and, you know, displaying on the website and talking about regularly, weekly on the YouTube channel, is going to be, you know, pretty out there. You know, we're doing stuff now that some of these larger organisations are doing, but the only thing we're doing differently is we're notifying people. Now, you can probably tell by my voice I'm a little bit emotional about, you know, actually finishing the data logger off. You know, it's a year's work, over a year's work, that has been, you know, only within the last 24 hours completed, so I'm delighted. Let's have a look at some of the data then, because I'm pretty sure that you're probably feeling a bit sick of just looking at that raw data on there. But I'll just quickly tell you, before I get onto Excel, what we're looking at. So the first set of numbers, separated by the commas, is the magnetometers, 1, 2 and 3. These are separate magnetometers with their own breakout boards and their own transmitters. The next is the heading, and don't worry about 1, 2 and 3 not being the same numbers. There's a little calibration to go when we finally get it in its resting place, that place where it's not going to be interfered by too much by temperature, because these magnetometers are temperature sensitive, and that's why we're going to put temperature sensors on each magnetometer, so that we will see that if the temperature starts to increase and the magnetometer reading starts to give random uncertainties in the data that we collect, we'll know it's simply because of temperature, and over a week we'll see that in a regular pattern. Let's have a look at Excel. Let's just finish off then quickly. So we've got the heading, it's the second set of numbers, and then we've got the time that the heading was recorded and the date that the heading was recorded as well. And I'll just show you just a simple chart with this data, and it's not going to be the final chart that we're going to use. It's going to be I'm just experimenting with, I want something very appealing, that looks good and also serves a function of giving us data by quickly looking at it over a period of time. So let's have a look at Excel then. So here we are. Within 24 hours of getting the SD card, logging the data, we're processing already. And this is what we want to be doing. Over on the two columns over here, we've got the magnetometers that have taken the readings. We've got the heading and we've got the time as well. Down below here on the chart, you can see the heading is spread out over the bottom and the amount of readings over the top. And we've got 3 series. The series are the magnetometers. So if I start clicking on any one of those lines, it will tell me what series it was. But as you can clearly see, around the 230 degrees heading, you can see a staggered line all the way up. Now, we can trim this line up nicely with a little bit of calibration. And we're going to do that when we get the magnetometers in their final place, where we're going to start recording from then on the data and where the heading is. But you can see the headings, it is around about, on average, 130 degrees on this at the moment. Now, don't worry about where the heading is. The magnetometer is in the back room. It's transmitting to the master, which is here by the computer at the moment, and it isn't even pointing north, so don't worry about it. What we're going to be looking at is these staggered lines are going to be around the 0 degrees, or just off, or just below. So there's a bit of processing to do. You can see there's a few random uncertainties in a few of the readings. Those we can just completely eliminate, or it could be that there is something genuinely affecting the magnetometers. And this is what science is all about, refining your data so that you get accurate readings. But I think that for now I would discard that if we was looking at this seriously, after it had been calibrated. When the temperature starts to go up, it might fluctuate a little bit, we'll see. But I'm happy at the moment. All 3 are within a certain amount of degrees, and it's not calibrated, like I say, but we're getting the data, and this is what we set out to do. So we've got the number of readings. Again, what I like about Excel is as you zoom out or zoom in, it crushes up the data sets for you, and likewise with the heading as well. If I start widening the chart out, it will start giving us a more accurate reading down to 0.0 of a degree, so we can get accurate readings. So guys, here we are. We've come quite a way over the last year. It has been frustrating that it's taken a year to get this far. We set out in search of data, and now we're getting and collecting the data. The magnetometer station is doing what it was designed, built and programmed to do now. There's a bit of tweaking to do with the processing so we can get a nicer chart. Perhaps we can have the magnetometer readings in separate colours. I can take this data, I can divide it by a certain amount so that I get an average, so I don't need 8,000 readings. I can just take the average. I can put alarm systems on it so that if we start getting big changes and it's not a random uncertainty, we can have an alarm flash on the master so that we can examine the data that we're collecting at that point in time. And that might even be during, let's just say the magnetic pole just starts to all of a sudden take off. The alarm can go off. We can have a look at what's going on the data, and we can say, look, we are definitely in the weak field lines. This gives people a heads up. Why is it important to give people a heads up? Well, over the last 20-30 years, let's just talk about what's been going on over the last 100 years. The magnetic pole acceleration has increased 3 or 4 times. So, the closer we get to the point where it's going to approach the weak field lines, which I think we are not very far away, that 40-degree mark, things will start to begin to happen quicker. But what have we noticed over the last 100 years then? Well, as these things have been increasing, right? Remember the chart I did before? I'll have to show you the guys at another time. We noticed that, earthquakes in frequency and magnitude increased. Volcanic eruptions increased in frequency. And, the weather over the last 20 years has took a dramatic change. These things, I believe, are all related to the fundamental planetary mechanics of the magnetic North Pole. If there was anything, as important that affected all these things, in my view, and I have to say this, in my view, it would have to be the magnetic North Pole. After all, when we look at Mars, we know that it had a magnetic North Pole. It no longer does now. It also no longer has water running on its surface, and it also no longer has an atmosphere. So, we're in a different. I've been talking to a few people. I know I'm a bit scatty about the subjects I'm talking about. I'm just trying to give you some information as to why I feel this is so important. This magnetic pole shift that we're in at the moment is a unique event. Last time it happened was 780,000 years ago. It's a really unique event, and yes, it's taking place during our lifetimes. But it can't be compared with any other magnetic anomaly that took place before that. And what I'm talking about is the reversals. You can't compare this reversal with any other reversals that we've had. And the reason why I say that is because, on average, the magnetic poles on this Earth used to reverse around 350,000 years. This one is different because it has taken over double to do that. My theory is that we shouldn't expect it to complete a reversal. We shouldn't do that because we don't know whether it will. Something could have slowed down in the magnetic process of reversals, and if that is the case, we could be learning firsthand, what happened to Mars when it lost its atmosphere. It's not about fear mongering. This is about science. It's about collecting data, and it is part of science to make predictions, and that's all I'm doing. I'm just putting that prediction out there. I'm just stating some of the facts. This magnetic reversal is 350,000 years overdue. It's happening right now in our lifetimes. Gosh, I mean, just that on its own is a unique opportunity to study this. And, there is no historical records of what actually takes place during a magnetic reversal. We don't know if it involves rotational axis shifts. No one really recorded anything at all back then. So, this is new territory. We know that they've occurred before because of the study of the Atlantic ridges. But what actually takes place during a reversal is still a big mystery. And there's no other scientist from any organisation that would disagree with me on that. This is new territory. This isn't to be compared with other magnetic reversals. I hear it all the time, guys. I don't know why you're so concerned or why you put so much time into it. The compass needle's just going to go to south and that'll be it. No. Absolutely not. Not with the data and, the information that we've gathered so far. We know that not to be the case. Not when we've studied Mars and found out, what changed its atmosphere, climate and condition that it's in today. We know that is not the case. This is real big news, guys. And, it doesn't get as much coverage as what it should do. The data's now going to start flowing. We're going to start monitoring the magnetosphere strength. We're going to start monitoring the heading of the North Pole. And we're going to learn a lot over the next few months just by studying this data. Really, to me, this is like putting something on Mars' surface. You know, it's a big deal. Now we're going to get going. You know, it's like we've been sitting at the start line for a year just waiting to get going. So, you know, I'm very excited. The fact now that we've got the data coming in, we can start setting up the you know, the magnetometer stations in their final places. You know, I've got to dig a you know, a 3-foot hole. I've got to purchase some more electronics, you know, some more sensors so that we can monitor the magnetic field strength. And I'm just looking forward to doing all this now. Like I say, it's not a problem now to put any sensors I want on any of this equipment. I mean, if ever I do get the time, I want to also incorporate this into a home automation system. It's going to go from strength to strength from here on, guys. You know, with what we can do with this, we've got a fantastic and pretty high-tech platform to work off. We can now add sensors. We can record the data onto, you know, an SD card. Also, another thing I'm going to do is with the system, for now I'm happy to just record off the SD card, but it's not too much of a problem now to get this linked up to Wi-Fi, connected up to the router, get this information transmitted live straight up to the website, so you can watch the graph being plotted as the information comes in there. Can you just imagine what it's going to be like when we start sending these stations out internationally? The more stations, the more readings, the more accurate the data, you know, the better the triangulation. But, you know, we just can't send this equipment out to, you know, anybody. They've got to have, you know, the understanding of, you know, what can affect the equipment. You know, it's got to be taken seriously. You know, there is some designs on this equipment. I'm not going to go on too much, guys. I'm not sure how much you want to know more about this, but there is some other designs for this equipment where, you know, we've got solar power and battery backup systems for the masters, so that if the electricity was cut on the property, it would still continue to collect data, not just from the magnetometer stations, because they would be backed up with a battery pack and a solar panel, but also the master as well, you know, so that there's no delay or you know, stopping of the data once it's started. You know, we can collect it. And I'm not sure whether to send that out as part of the package, you know, when we start transporting these different places on the Earth, you know. So I'm not going to go on about this, guys. I'm going to get back to work, getting a nice spreadsheet for us to look at. You know, hopefully by the end of next week we'll have these magnetometers put in their place. I don't think I'll have the FMG3 sensors yet. All depends. You know, if we can get some people to throw a few quid into the you know, the cash pot, you know, we can start ordering more stuff. It's as simple as that. I want to thank those people that have contributed to this. It's not just for us, is it? It's not just for us. The information over the years that we've been doing this channel has never just been for us. It was always meant to be shared with others, you know. So again, I feel a little bit emotional that we've got it here. You know, it's sometimes, you know, people will never appreciate the amount of hours that this sort of stuff takes to get finished. But, you know, it was, like I say, it was never just for us, was it? It was for everybody. And, you know, that's why I didn't charge a subscription fee on this channel. I give it freely, and I just left it down to people to donate if they wanted to. So, you know, I'm going to keep it that way as well. You know, this has been a group funded effort. You know I've done a lot of the work on the equipment, the building, the studying of this, you know, anomaly for over the years that I have, but nevertheless I could not have done it without the you know, the group funding. So, you know, it's an achievement for those that have supported this channel, and it does save lives. I, I would like to think that it already has saved lives. You know, people that have picked up on the information, especially when we've talked about, you know, genetically modified seeds, and, you know, are they better than the ones that have stood the time and even, you know, evolved naturally with the earth? You know, I do like to believe that there are farmers that have listened in and said, no, we'll stick with the originals. And as a result of that, you know, it's paid off well for them, in the fact that they've not had to remortgage their farm on the purchasing of genetically modified seeds, which have failed due to the fluctuation in the climate that we're experiencing right now, as I believe, through the magnetic reversal. So, guys, I'm going to end it here. I just really wanted to, you know, give you the breaking news on this. In fact, I might put that up in the title, breaking news. You know, we've got somewhere with the data logger. So, you know, tune in. You know, you know, every step now that I make in progress, you know, I'll gladly share with you guys, and not only the progress, but, you know, the data as well. We're going somewhere now, guys. Link down there if you want to contribute towards this. You know, it's a good time to now. You know, I don't think you'll get the same satisfaction from anyone else, you know, that has you know, put such an effort in. You know, it's up to you guys. Anyhow, the link's there. I won't go on. I think I'm just talking for talking's sake now. So, you know, take it easy, guys, and I'll catch up with you over the weekend sometime. Okay, bye for now.